He says, in the sketch alongside, AB is a vertical line, right? So again, we have got AB here. That's AB. It's a vertical line. Then BPQ are 3 points on this, rather in the same horizontal plane, which means they are like the floor in the classroom. And AB is like me standing upright. Now, for a June exam, I indicated for you that this angle here will be 90 degrees. So I made it easier for you. Okay? Then, so what this means is AB is perpendicular to triangle BPQ. Right? It also means that this angle is also 90. Right? So we have two right angled triangles there. And one triangle which is not right angle. So triangle BPQ is not right angle. Right? So APB is equal to AQB. Right? That's given there. So APB is equal to AQB. They are both equal to alpha. So they are indicated there. They are both equal to alpha. Right? And then PAQ is equal to theta. That whole angle is equal to theta. And then lastly, AB is equal to H. So that's AB there is equal to H. So the question says, show that PQ, this is P, that's Q, is equal to H times 2 times 1 minus cos theta over sine alpha. Right? Now, just as a hint from experience, whenever you are doing a question like this, the moment you see a square root, it's a clue that you are supposed to use the cosine rule. But the cosine rule is the only one which can help you to end up having cos inside the square root. Okay, that's the only one. So I need to apply my knowledge of the cosine rule. But in the denominator, I've got sine alpha. That's an indicator that I might need to use a trig ratio for sine, or I might need to use the sine rule. But it's most likely a trig ratio for sine. Right? So remember, PQ is here. Right? And I need to calculate that PQ. Now, I don't know the length of PB, and I don't know the length of PQ. Following that. So what that means is, if I'm to use the cosine rule to calculate PQ, I need to know what is the length of PB, what is the length of BQ. Also, I will need to know what is the size of this angle. Okay? Furthermore, if you look at it, because here we are told that this whole angle here is equal to theta, it also means that we have another triangle APQ. So we have got 4 triangles in the diagram. Okay? 4 triangles. Okay? So since I've got this theta here, all I have to do is determine the size of AQ in terms of H and also AP in terms of H. So I need to know what is the length of AP, what is the length of AQ, because I already know what is the size of this angle. Remember, to use the cosine rule, you must be given an angle and the sides that form that angle. Alright? So let me do that quickly. So, to start with here, allow me to calculate the length of AP. So if I calculate AP, means this is my reference angle, and this side here, AB, will be my opposite side, and obviously this will be my hypotenuse, and that's my adjacent side. Also for here, this will be the opposite side, that's the hypotenuse, and that's my adjacent side. Okay? You follow me there? Huh? I hope you're following. So first thing I'll say, in triangle APB, right? In triangle APB, if I use trig ratios, obviously, to calculate the length of PH, I know the opposite side, I know the reference angle, so I have used sine it will be sine of alpha, okay, it's going to be equal to the opposite side, which is h, divided by the hypotenuse, which is AP. You following that? So what this means is that I can swap the sine alpha and the AP. So AP is going to be h over sine alpha. Okay? Then I need to do the same for triangle ABQ. So in triangle ABQ, okay, again I'll say sine alpha will be equal to the opposite side, which is h divided by the hypotenuse. Now the hypotenuse is going to be AQ. So AQ will be equal to h over sine alpha. Are you following that? Okay. What's the objective? To calculate the length of PQ. I can't use triangle BPQ because I have a problem with this angle. If I knew that angle, then I would calculate PB and calculate BQ. Yes? No, I've incorporated that by using trig ratios. I've incorporated that. Remember, if a triangle is right angled, you can use trig ratios. So I've incorporated that.
So what do you do?
Okay?
So you just like it's not actually given that
It's not given, but based on the fact that AB is vertical and points BPQ are in the horizontal plane, it means that AB is perpendicular to PB, also perpendicular to BQ. Remember, I said earlier when I started that AB is like me standing. I'm vertical. Right? Then points BPQ are like some points on the floor. So if you draw a triangle up to me, let's say there's a vertex at me, and then you've got two other points there, I will be perpendicular to the floor. So the angle between me and the floor is supposed to be 90 degrees. Alright? So if you have got a vertical plane and a horizontal plane, the angle between them will be what? 90 degrees. Right? Okay? So we are here now. Then the next thing, since I know the length of AP and AQ, I can now use the cosine. Okay? So if I use the cosine rule, it will be like this. Right? Remember, I want to calculate BP, sorry, PQ. So it will be PQ squared is equal to. Now, do you see that there is AP here and AQ? I know those lengths, right? And the angle between them is theta. So it's going to be AP squared plus AQ squared minus 2 times AP times AQ times the cosine of theta. That's my cosine. Okay? Then let's carry on. So PQ is going to be equal to, now my AP is equal to H over sine alpha. Okay? So I'll put here H over sine alpha. Then I have to square this plus AQ is also H over sine alpha. Then I have to square this minus 2 times AP is H over sine alpha. And AQ is also H over sine alpha. Then times cosine of theta. Well, I must be honest with you that your knowledge of algebra is very, very important to simplify it. So, to simplify it, we'll get h squared over sine squared alpha plus another h squared over sine squared alpha minus. Then here we multiply those two, we end up getting 2h squared over sine squared alpha times cos theta. Okay, so this is PQ. This is PQ squared. It's not PQ yet. Okay? Are you following that? Now, do you see that we have got a common factor? These two are like terms. So I can write them as PQ squared equal to, the denominator is the same. So I can add the numerators. I'll get 2h squared over sine squared alpha minus 2h squared over sine squared alpha times cosine of theta. Do you see a common factor? Right? Let's take out the common factor. So on the next page, we have PQ squared is equal to 2h squared over. Well, let me check my expression before I write. You see this 2 here, this 2 here, it comes from that 2h squared. So let me take out that 2h squared. So this will be, well, let me keep it inside and I'll take out h squared. So I'll take out h squared over sine squared alpha. Because obviously, if you are doing the question, you must look at what you are trying to show. So this will be times 2 minus 2 cos theta. Okay? Then allow me to take the square root on both sides. If I take square root, I'll end up getting PQ is equal to the square root of h squared over sine squared alpha times 2 minus 2 cos theta. Okay? Alright? Now, this h squared over sine squared alpha, it's a perfect square. So I can find its square root and then take it outside. So I'll end up having PQ is equal to h over sine alpha. This will be times the square root of, now I have to factor out the 2 there. I'll take out the 2 times 1 minus cos theta. Right? I can then finally write this as PQ equal to h times the square root of 2 times 1 minus cos theta all over sine alpha. Okay, and then I'm done. So I've shown that this I've shown it. I hope you're following. I hope you're following. All right.